Okay, problem 1 on the test study guide for test 17. The total weight of the carbon varied inversely as the total weight of the fluorine. So as soon as I see the word varied, I know it's a variation problem. This is an inverse variation of carbon's weight inversely as fluorine's weight. So first thing I would do, if carbon varied, C equals K, inversely divided by fluorine F. Next thing I look for is how much they weighed at one moment. So right here, carbon weighed 450 when fluorine weighed 8. So 450 equals K over 8. Inverse variation, a lot of times we create a proportion by putting that over 1. Cross multiply 1K equals 450 times 8, which is 3,600. And once I know that K is equal to 3,600, I go back and substitute back in the original variation statement. C equals 3,600 over F. What was the weight of the carbon when fluorine weighed 2 grams? So they want to know C when fluorine weighs 2. 3,602 gives me 1,800 grams. Example, or problem 2, an amount of ideal gas. As soon as I see the words ideal gas, I know it's that type of problem. It says volume was a constant, so typically it's PV over T equals PV over T. Volume is held constant, which means that they can be thrown out. So initial pressure over temperature equals final pressure over temperature. Temperature must be in kelvins, which I can see it is. Final temperature is what we're looking for. So looking at this, the pressure was found to be 800 newtons per square meter when the temperature was 200 kelvins. So initial pressure 800 newtons per square meter over initial temperature 200 kelvins equals final pressure 1200 newtons per square meter. It says increased to 1200. So again, be careful. Sometimes it says increased by, decreased by, so be careful of that. But increased to, it should be that one on the test. Final temperature is what we're looking for. A reduction of fractions is legal in this case, so 800 over 200 can reduce to 4 first. So if I cross multiply now, it just makes the number smaller, it's easier to deal with. So 4t sub 2 is equal to 1 times 1200, which gives me t sub 2 is equal to 300. Unit of temperature again is kelvins. It should be that way on the test. Number 3, 2 containers are on a shelf. The first one contains 12% iodine, the other contains 77% iodine. How much of each should be used to get 80 liters of a solution that's 38% iodine? So everything's about iodine, which is good. And what we have to establish is what we're mixing together and what we're going to end up with. So we've got a 12 and a 77 that we have. We're mixing those together. How much of each should be used? So we're mixing those two together. So if I was to draw a picture of the situation, I got a 12% iodine solution being mixed with a 77% iodine solution. And we're trying to get a 38% iodine solution. This is a classic one that we started off with when we first saw these problems. 2 weak plus 2 strong makes something in between. We're trying to get 80 liters of 38%, so we have the exact value of this. We don't know either one of these. They both have to be represented using variables. Let one of them be x, the other is going to be the total minus x. And if we compare the boxes, this box plus this box should equal that. X plus 80 minus x equals 80 is valid. Then we multiply percent times amount plus percent times amount, and 77 times 80 requires a calculator for me, so 77 times 80 comes out to 6,160. The battery in the camera died. I'm going to start back where I left off, hopefully be able to splice these together. If they're spliced together, it worked. Otherwise, there'll be 2 videos. 6160 minus 77x is what we get out of that, and then 38 times 80 is 3,040. So that's what we get for an equation, and then if I 12x and negative 77x make negative 65x, the 6160 moves over here. We subtract those, we get 3120, negative 3120. Just for verification purposes, 3040 minus 6160, negative 3120. So then negative 3120 equals negative 65x, so we simply have to divide by negative 65 now. And we get 48. Keep in mind on these chemical mixture problems, we need to establish what each of these things represents. Or we have to answer everything. It says how much of each should be used. So 48, we're dealing with liters of, and X is right here in the 12% container box, so 12% iodine. How much of each implies we need to know the 77% also. If this is 48, 80 minus 48 makes 32 liters of the 77% iodine. So that would be the answer to that one. I would expect the one on the test to be similar. We're going to get a couple answers like that. Number 4, the ride in was quick as the speed was 360 kilometers per hour. The ride out at 120 kilometers was much more relaxing. Total time in and out was 12 hours. What was total distance? They don't specify this, but it seems like if I'm going in and coming out, chances are I'm going the same distance. So the distance in, the distance out, distances are equal to each other. I would assume that in this problem. And then once I establish how the distances relate to one another, then I get to my rate time distance chart. The categories are in and out. The ride in, the speed was 360 kilometers per hour. The ride out is 120 kilometers per hour. The total time in and out was 12 hours. Anytime they give you total or round trip time, let one time be t, the other is going to be the total minus t. I've said this 100 times. Some of you still aren't doing it right. I don't know how else to say it, but total time, t, total minus t, that's how you do it. 360 times t is 360t for the distance going in. 12 minus t being a binomial, distributive properties necessary. 12 times 120 is going to be 1,440. And 120 minus t is going to be minus 120t. And again, the distances are equal, so set distance in 360t equal to distance out 1440 minus 120t. Move the t to the other side. Change the sign, so 480t is equal to 1,440. We take 1440 divided by 480. It says t equals 3 hours. Again, on all these problems, be careful to answer the question. The total time in and out was 12 hours. What was the distance in? Distance in is 360t. So we take 360 times 3. Unit of distance is kilometers. I know that because the speeds are in kilometers per hour. So kilometers per hour, kilometers. So 1,008 kilometers answers the question. Again, anything with a variable represents something you don't know. Time in, 3 hours. Time out, 12 minus 3, 9 hours. 12 times, 120 times 9 is 1,080 kilometers. Distances are equal in that case. Number 5, the chemical formula for sodium hypochlorite is NaClO. So NaClO and NaClO. So we have molecular weight here. So each sodium atom weighs 23. The chemical formula has one sodium atom in it, so 23 is the molecular weight of the sodium. Each chlorine atom weighs 35. We have one in the formula, so 35 is the weight of the chlorine. Each oxygen atom weighs 16. We have one in the formula, so 16 is the weight of the oxygen. Add them up, 23 and 35 is 58. 16 makes 74. So each molecule of NaClO weighs 74 moles. It asks the percent of the total weight is sodium. So we're looking for the percent of sodium. The percent of everything is 100%. So 74 goes with 100%, 23 goes with P. Now it's just a matter of making proportions. So 23 over 74 is equal to P over 100. Cross multiply, we get 74P is equal to 2,300. Divide by 74. Comes out to 31.08%. And don't expect nice, pretty integers on this. It'll be what it is. But again, the total weight is going to represent 100%. The part you're looking for is going to represent P%. You just got to cross multiply at that point. Number 6, simplify a plus 4 over 3 over a plus c. We have a complicated fraction here. We need to fix it. So the issue is the 3 over a. This a right over here is minding its own business to begin with. So a, I'm going to put that over 1. And then for this fraction, I'm simply going to multiply each object on it by a. So times a on top, times a, and times a on bottom. There's 2 terms on bottom. So 4 times a on top makes 4a. 3 over a times a makes 3. C times a makes plus ac. Once we get the second fraction fixed, so it's just a now basic simple over simple. Now we're going to get a common denominator of 3 plus ac. This one has no bearing on a common denominator. So this first fraction is a over. All right, I need a 3 plus ac on the bottom, so I had to put a 3 plus ac on top. The second fraction is perfectly fine. It already has 3 plus ac on the bottom. So it just stays 4a over 3a plus 3 plus ac. No change is necessary. And then what's left to do is to distribute and then combine like terms. So all together on the top here, make a big fraction bar for the whole top. A times 3 makes 3a. A times ac makes plus a squared c plus 4a all over 3 plus ac. And the final thing I would expect you to do is add like terms. If you don't do this, I will deduct points because you aren't finishing it out completely. 3a plus 4a makes a total of 7a plus a squared c over 3 plus ac. Reduction's impossible because this has a, this has a, this has a, but that doesn't. Both of these have c, but both of those don't. So you can't reduce it, but that 3a and 4a do add together. Expect something similar to that to happen on the test that you're taking. Number 7, same idea, same type of problem, same issue. This is a complicated fraction. We need to multiply everything by k to get rid of the fraction. So times k, times k, times k. So j over k stays exactly as it is, plus, on top 1 times k, this term 2 times k, this term m over k times k just gives plus m. At this point, looking at the denominators, k and 2k plus m, different denominators, no common factors, so I need to multiply this fraction times k over k, this fraction times 2k plus m over 2k plus m. So j over k stays what it was, and we're going to multiply 2k plus m on top and bottom. K over 2k plus m stays the same as it was. And we're going to multiply top and bottom by k. And now both denominators have a k and 2k plus m, so now they're like terms, or they're common denominators. Distributive property, multiply stuff together, get everything as simple as possible. So the end result of the first fraction, j times 2k makes 2jk, j times m makes jm, k times k makes k squared for the second fraction. Common denominator of k times 2k plus m goes in the bottom. And this one I can't add any like terms because there aren't any, so that's the best I can do. If you really wanted to multiply the k through that, you could. I'm fine leaving the bottom in factored form, but the top does need to be simplified completely. Number 8, we have some i's to powers. We also have some negative numbers inside of radicals. So we want to deal with the negatives and the radicals first. So I'm going to leave 4i to the 4th as is. I'm going to leave 2i cubed as is for right now. The negative in the radical makes an I outside the radical. So 5i times the square root of 9. Negative in the radical, second negative in the radical being multiplied together. So I'm going to get I times the square root of 7 times I times the square root of 7. So get those negatives out of the radical first, then it's just an easier problem to deal with. So 4i to the 4th minus 2i cubed, we'll worry about those in just a minute. Square root of 9 is 3, being multiplied by 5i makes a total of 15i. These are being multiplied, so make sure that equals 3. That 3 multiplies by the 5, not added to the I or something like that. So I've seen people mess that up. Multiplication, everything there, 3 times 5 makes 15. Square root of 7 times the square root of 7 makes 7. I times I makes I squared. So again, all this stuff's being multiplied together to make one term. The square roots of 7 make a 7. The i's make an I squared. Once you get everything down to just a bunch of stuff with either real numbers or i's, then you start worrying about the powers of I. I to the first is I squared is negative 1, I cubed is negative I, and I to the fourth is positive 1. And that's all we have over here is those four things. So if we just replace them with what they equal, replace I to the fourth with 1. Again, 4 is being multiplied by I to the fourth, so 4 is being multiplied by its replacement. I cubed is negative I. 2 is being multiplied by I cubed, so 2 is being multiplied by its replacement. 15 I to the first is perfectly fine the way it is. 7 is being multiplied by I squared, so 7 is being multiplied by its replacement, negative 1. Alright, if I simplify each object then, 4 times 1 is 4, minus 2 and minus I make positive 2I, 15I is plus 15I, and 7 and negative 1 make minus 7. Real sum, 4 minus 7 is negative 3. Imaginary sum, 2 plus 15 is plus 17I. Number 9, same type of problem. Once again, negatives inside of radicals, deal with those first. So this makes it I, the square root of 25 is still there. These are being multiplied together, so I got I times the square root of 3 being multiplied by I times the square root of 3. And then minus, I can go ahead and make that 32, it's not going to hurt anything to evaluate that. Be careful, it says 2 to the fifth, not 2I to the fifth. I've seen people do that on this type of a problem, but put imaginary i's in that aren't really there, but 2 to the fifth is just 32. Square root of 25 is 5. It's being multiplied by I. Square root of 3 times square root of 3 makes 3. It's being multiplied by I, which is I squared, and minus 32. And once again, I'm just going to go down to I squared. I to the first equals I to the second is negative 1. There's my I to the second. So 5I is fine. 3 is being multiplied by I squared, replaced with negative 1, minus 32. 3 and negative 1 make minus 3. Real sum, negative 35. Imaginary sum, plus 5I. There's our answer. Number 10, simplify. We're multiplying imaginary complex numbers. 3 plus 7I times 3 plus 4I. I like to write them in A plus BI order, which it started off as. I brought it down here just to be able to draw the FOIL on it. First times first is 9. Outside times outside is positive 12I. Inside times inside is positive 21I. Last times last is positive 28I squared. You always get an I squared term when you're multiplying complex numbers, so you get a real 2I to the first and an I squared. All I squared does is change the sign. So again, I squared is negative 1. Negative 1 times positive 28 is negative 28. Real sum, negative 19. Imaginary sum, plus 33I. Number 11, same type of problem. Notice these aren't written in A plus BI order, so I would probably write it on my paper, negative 1 plus 4I and 5 plus 2I. It works in that order too, it's just I really like real than imaginary order when I'm dealing with complex numbers. So, first times first, negative 1 times 5 is negative 5. Outside times outside, negative times positive makes negative. 1 times 2I is 2I. Inside times inside, positive times positive makes a positive. 4I times 5 is 20I. And last times last, positive times positive makes a positive. 4 times 2 is 8. I times I is I squared. Once again, I got an I squared term. 8I squared is just minus 8. Real numbers, negative 5 and negative 8 is negative 13. Imaginary is negative 2 plus 20 is going to be plus 18I. Addition because the signs are the same, subtraction because the signs are different. In each case, the bigger number determines the sign of the answer. Number 12, add 4 at an angle of 25 and 8 at an angle of 145. Write the final answer in polar form. So, 4 cosine 25, 4 sine 25. IJ. So, I get 3.63I for this one. Plus 1.69J. Same for the second vector, it's 8 angle 145, so 8 cosine 145 gets me the I. 8 sine 145 gets me the J. So this vector here in rectangular form is going to be negative 6.55I plus 4.59J. So to get the solution, I simply have to add the i's and j's together. So 3.63 minus 6.55 and 1.69 plus 4.59. Give me those two results. So negative 2.92 I plus 6.28 j. Again, that represents the sum in rectangular form. What I need to do at this point is convert it back to polar form. Step 1 for polar form. R is equal to the square root of the squares of these two numbers. Do not include negative numbers in this step. So you write it down and then apply it. So square root and then 2.92 squared plus 6.28 squared. In parentheses equals 6.93. Step 2, once again, no negative signs. Alpha is equal to the inverse tangent of the absolute value. That's why the negatives get thrown out. Second divided by first. 6.28 over 2.92. You do have to hit the inverse tangent key. So hit second tan. 6.28 divided by 2.92. In parentheses equals 65.06 degrees. Final step. We deal with what quadrant we're in. So if I imagine my coordinate axis, I'm going left and up. That puts me in here somewhere. That's the second quadrant. In the second quadrant, theta is equal to 180 minus alpha. That comes out to 114.9. Yeah, 114.96. 94. Just verify that, just to be safe. 180 minus 65.06 is 114.094. Perfect. Okay. So, magnitude 6.93, angle 114.94. I'm expecting to get all the way to that point on that problem. So, your calculator is going to be doing all the calculation for you. You have to know how to do it. The entire process for doing this is on your formula sheet. It's just a matter of knowing how to type in your calculator correctly and being careful with technique. Again, squaring creates positives every time, so ignore the negative. Absolute value bars, ignore the negative. This is the only place the negative matters. Which direction you go, which quadrant you end up in. So be careful of that. 13. Fractions and decimals in these problems. We want to get rid of the fractions and decimals. So if I multiply the entire top by 10, common denominator of the fractions, 10 divided by 2 is 5 times 3x is 15x. 10 divided by 5 is 2 times negative 1y is negative 2y. And 10 times 10 is 100. So 15x minus 2y equals 100 is equivalent to 3 halves x minus 1/5 y equals 10. The bottom equation, 2 decimal places, 2 decimal places, 1. So now it has 2. Just drop the decimals off. So I get 2x plus 40y is equal to 416. At this point I have to get rid of something. I'm going to get rid of the y's because the signs are already opposite. So I'm going to multiply the top equation times 20. 20 times 15x is 300x. 20 times negative 2y is negative 40y. 20 times 100 is 2,000. And that gets me 302x is equal to 2,416. Divide by 302. Get x equals 8. Once I know what x equals, I go back to one of my equations. I'm going to go to that blue one. So 15x minus 2y equals 100, which means that 120 minus 2y is equal to 100. So negative 2y is equal to negative 20. Divide both sides by negative 2. Y equals 10. Could have also gone back to the red equation. 2x plus 40y is equal to 416. That's 16. So 40y is equal to 400. Divide by 40. Y equals 10. Either way you get 10. So x equals 8, y equals 10. Word pair. It comes out to a nice pretty answer there. I'd expect them on the test to do the same. Number 14, solve. It doesn't specify how to solve, but right now we have factoring, which that wouldn't factor very easily, if at all, and we have completing the square. So I'm going to assume completing the square on this one. So if I start off with 4x squared plus 3x equals negative 2, Divide everything by 4. X squared plus 3/4 x gap equals -1/2. Do reduce fractions when possible in this step. So divide by 4, you get 1. Divide by 4, 3/4. Divide by 4 reduces to 1/2. If I go ahead and complete the square, half of 3/4 is 3/8. I got to do 3/8 squared to both sides. So on this side, plus 9/64. Common denominator 64 means I got to multiply top and bottom of this by 32. So throw that out and replace it with that. What that ends up giving me on the left-hand side is a perfect square trinomial, plus in the middle because the middle sign's plus. Square roots of the perfect squares, just drop the powers off. X plus 3/8 squared. On the right-hand side, common denominator 64 already happening. -32 plus 9 is -23. This right here is the one fraction I never reduce on these problems. Right here, when the square equals a number, leave that as is, even if it reduces. Square root of x plus 3/8 squared is x plus 3/8. The square root of 23/64 is the square root of 23 over 8. The negative makes an I show up. Okay? 23 doesn't have an exact square root, it stays under the radical. The minus makes the I. Square root of 64 on the bottom is 8. Notice this radical does not extend to the bottom because I actually evaluated the bottom. And it's plus or minus that object. The square root on the right-hand side is where the plus or minus goes. And then we just throw the 3/8 over to the other side, change its sign, but put it in front of the plus minus sign. So -3/8 goes in front of the plus minus sign. The square root of 23 over 8 times I goes after it. So there's your answer. With an imaginary answer, I like them separated like that. If this were real, put it as one fraction, but I'm not going to be nitpicky about that. If you put it as one fraction with imaginary, it's fine. If you get the right answer, don't worry about that. 15, find the area of this figure. Dimensions are in meters. The figure is a triangle with a semicircle attached to it. So looking at the triangle, I need to know the height of the triangle in order to find the area of the triangle. And what allows me to be able to find the height of it is the fact that this side over here is 8, a radius of 4, and a radius of 4 makes a diameter of 8. So this side and that side are the same, making an isosceles triangle. So if I split that in half and do the Pythagorean theorem, 2 squared plus h squared is equal to 8 squared. H squared is equal to 60, so h is going to equal the square root of 60. And we can approximate that. Square root of 60 is 7.75. All right. And so if I look at the area of the triangle is 1/2 times its base times its height. Okay? The base of the triangle is 4. Be very careful. A lot of times we split this in half for the purpose of finding height, and the people say that height is 2, the base is 2. Half the base is 2, the whole base is 4. So be careful of that. The height is what we found, 7.75. So if I type that in my calculator, 1/2, also known as 0.5, times 4 times 7.75, we get a triangle area of 15.5. And again, that just represents that area. We still have a semicircle to deal with. Semicircle, right here, radius of 4. So the area of the semicircle is going to be 1/2 times pi times the radius squared. So 0.5 times 3.14 times 16 comes out to 25.12. So the total area of this figure is going to be the sum of the triangle and the semicircle. So 25.12 added to 15.5, 40.62 meters squared. Expect a similar looking figure, obviously different dimensions on the test, but an isosceles triangle problem, more than likely, finding the height will be necessary to find that area.